Hello everyone, so welcome to today's Tech Excellence meetup. Our vision is to raise the bar of technical excellence across the world, and the following is an overview of our speakers for this year. Please make sure to join us on Meetup so that you can get notified about our future events. Also, you can like this video and subscribe to us on YouTube. And furthermore, you can follow us on LinkedIn and Twitter, and also join our GitHub page in case you have any technical discussions. So for today, I'm really excited that Daniel Moka will be joining us. So he already has several years of experience in developing high quality software and also helping software development teams to develop better software. And he also has his freelance agency, Moka IT. So I'm really excited regarding the topic for today. As you've probably noticed, if you're applying TDD, quite often you might get questions from other people. Why are you applying TDD? Does it really pay off? So the theme of this session is how to convince management and your fellow colleagues to apply TDD. So thanks again, Daniel. I'm really looking forward to this session.
Thank you very much for introducing and also inviting me to this meetup. It's a pleasure to be here and welcome everyone. I would say let's get it started, right? So we are here at the Tech Excellence meetup, and the title is How to Convince the Management and Your Colleagues to Apply Test-Driven Development, TDD. First of all, let's see the agenda of this talk. At the beginning, I'm going to introduce myself, shortly talking about what I'm representing in the software engineering space. After that, I'm going to talk about how to sell TDD to the management. We're going to talk about the unique selling point TDD has. We can convince others to use it. After that, I'm going to go into details and talk about convincing your colleagues, your developer colleagues, to apply test-driven development. Here we are going to talk about the killing features of TDD, and I'm going to present why TDD is superior to test after development. And last but not least, we're going to have the QA, question answer sections. So if you have any questions, feel free to post in YouTube, and then probably we will have time for that, and I'm happy to answer those. Then, introduction. My name is Daniel Moka. As you heard, I'm a software craftsman from Hungary. Software engineering is both my passion and my profession. I'm interested in everything which relates to software engineering and everything which helps to produce quality software, such as test-driven development, domain-driven design, hexagonal architecture, writing clean code, but also I am a big fan of the extreme programming practices and also soft skills such as how to use pair programming, mock programming, etc. I've experienced in a wide spectrum of domains in the last 10 years. Sort of, I was involved. I've experienced in the medical and healthcare domain, also in gas and oil industry, also sort of blockchain, enterprise resource planning system, warehouse management systems. Also, I had projects to build digital mapping solutions. And in all my experiences, I was searching for language agnostic skills, which can be applied in every context and which can be transferable from one domain to another. And that's how I ended up with test-driven development. I'm a test-driven development advocate. You can find me online. Last year, I initiated the creation of the test-driven development manifesto. It's online, you can check it out, which helps anyone who wants to get started with TDD. And also last year we organized, and of course I did it with my friends, and also with those friends we organized the first international test-driven development conference, which was a blast. We had a great time with really great speakers. It's on YouTube. You can find them and you can rewatch those sessions. I really recommend. And yeah, as Valentino mentioned, that I have been helping teams and individuals to apply best software engineering practices and to produce quality software. So that's all about me in a nutshell. Let's do. So first of all, I have to ask question why we are here, why I'm sitting here, why we are sitting in the other side of the screen and you are watching me, why we are here, what is this session about? Well, first of all, TDD is still not widely adopted in the industry. I feel that it deserves much bigger adoptions. TDD has really unique features and killing features, which makes it really powerful. So it should be. I'm of the opinion that it should be used in by much more people by much more companies. So in this session, we are going to learn about how can we convince them to apply it and how can we reason TDD so they will understand the real power of it. Next to that, yeah, we are also here because TDD is still a highly misunderstood topic. A lot of people still think that TDD is equal to just writing tests, but it's not about that. It's just a different way of working. Also, some people still think that TDD is a testing methodology. It's also not true because design methodology, I'm going to talk about later why and why it is that. So here, hopefully with this session, with this presentation, I can highlight really the main points, the main characteristics of TDD. And of course, I think a lot of us can relate that we get, many times we get pushbacks from the management, either from the management or from our colleagues that TDD doesn't work or they don't believe it because it's religion, for example. And we get these pushbacks because they are conservative or they have bad experience with TDD or simply they just don't care, right? So in those situations, we have to somehow reason about this TDD and we have to sell it or convince them to use it. So in this session, we are going to talk about how can we do this. Let's do it. So what is TDD? Yeah, this session is not about how to do TDD. It's about why we are doing TDD. But maybe some of you don't know what TDD is. So just shortly, in a nutshell, I'm going to talk about what is TDD, what are the main points about TDD. Yeah, TDD is a design methodology where our code is guided by our tests. The tests are input of our design, but they are also a byproduct. It is both an iterative and an incremental way of working, which consists of three main phases. A cycle consists of three main phases. First is red. After that, the second is a green, and the third one is a refactor phase. As you see in the slide sheet, the first phase is the red, where we have to write a failing test. We have to write a failing test which is sufficient to fail and not more. After that, we are going to write some production code in the green phase, which will make this failing test pass. Minimal production code is very important. And at the third step, we are going to apply refactoring, renaming, etc. We are going to do refactoring, what we can do. And after that, we do this cycle again in iterations. And we are building up our applications in an incremental way. So shortly, that's what TDD is about. So let's see now why we need to use TDD. Yes, first of all, yeah, what do the management want, right? So as I said, the first part of the session, I'm going to talk about how to sell TDD to the management, how to convince them. So what do the management want? What they want is fast and stable releases, right? They want to ship software fast and in a stable way, without bugs, without defects. They want to do it in a lower cost, right? The most important property or characteristic of a software is the cost of change. So really want to minimize this cost of change, or the management want to minimize the cost of change because it's all about money, right? Next is, they want to have more satisfied end users. We as engineers, or we as companies who are producing software, our most important task is to make the customer happy, right? To make them happy, to fulfill their wishes. So of course, that's what the management want ultimately. And last but not least, of course, they want to have a bugless and working software, which solves the given problem domain. So let's see, first point, what TDD offers. TDD reduces the number of defects in the software. And there are two main reasons for that. First of all, because when we use the TDD flow, we're gonna have tests for every behavior we are writing. Therefore, everything what we write will be tested. So we know that it will work. So we also know that it doesn't contain bug, right? So it is one of the reasons why it will reduce the number of defects. And second of all, when we use TDD, we can produce a much stronger safety net in the form of automated test, which can help us, which can protect us from introducing bugs in the future, defects in the future. So it will also help us to reduce the number of defects. It can lead to two things. First is high reputation, right? Because once we introduce a defect or a bug in the software accidentally, then it will decrease the reputation. So if we don't have bugs in our software, then we will keep our reputation high. They will like us. So the customer will be happy, and that's what we all want. And of course, reduce cost. And I'm going to show you something in the next slide sheet, and you will understand why it's reduced cost and how much it will reduce. Finding bugs early is cheap. If you catch a bug while coding, it will cost you $80. If you catch a bug with your CI pipeline, it will cost you $240. If you catch a bug with your QA process, it will cost you $960. If you catch a bug in production, it will cost you $7,600. And I have to tell that these numbers, they might look big, but they are not big at all. I think they are pretty moderate numbers, and I think all of us can relate that these numbers are, I would say, even low. And in real life, we can pay even much more for a bug, especially for a financial application. They can be up to millions, even more. So bugs are super expensive to fix them. So here, as you see in the graph, the relative cost of fixing the defects, as you see, the later we find it in the development process, the more it will cost, and it is an exponential thingy. And the question is very steady in this picture, right? Because we are somewhere at the dev, but even before that, because TDD really makes sure that we don't produce bugs. Of course, it doesn't mean that we won't produce bugs, right? We are humans. We can make mistakes. We can be tired. We can produce bugs. We can miss out cases. But it's really coming from the practices of TDD or coming from the way of working of TDD. It really helps us to minimize the number of defects. So it will lead to high reputation and reduced cost. What TDD offers? The second thing, TDD increases agility and productivity. First of all, we have to talk about what is agility, what is being agile, right? It is a very hyped topic lately. And what is agile? Well, agile is simple. I mean, in words, it's about delivering value to the customer in a short feedback loop with continuous improvement. We want to make their life happier early, and we want to get feedback as soon as possible and refine the software. TDD helps us to be more agile. Why? Because of the TDD, as I mentioned before, we will surely have a working software, so we know it works, and we will have a strong safety net. And because of that, we can deploy, or we can push our code. We can apply continuous integration, so we can push it to the master early with high confidence. And we can also apply continuous delivery because we know it works. And we also know we didn't produce bugs because we have a strong safety net. Therefore, we can deliver the software earlier, so we can get the feedback earlier from our customer, and after that we can refine it. And that's it. That's what Agile is about. And of course, it also increases the productivity, because the productivity is also correlates the internal quality of the software. And because of the flow of TDD, we have a strong safety net, but also by following TDD, we also end up having higher quality software, because we have to always refactor the code. That's what I mentioned at the beginning. The third step of every cycle is that we apply refactoring, so we will keep our code in a good shape. Therefore, we will be more productive and agile. And here is, and I think it's very, very crucial and important. I heard it from a good friend of mine, Mario Carrera, but I also heard the same thing from Frank Clement. They said, and sorry for the vulgar word, but I have to tell this: you can't be agile if your code sucks. You need to have a clean code. You need to have good code with a well-shaped test in order to be agile. If you don't have it, you always have bugs. You have to hunt them. You have to debug them, and you will always have problems with this. There is, I think we all know, there is no trade-off between speed and quality in software engineering, right? I mean, we should, if we delay refactoring, or if we delay testing, we won't save time. We will actually just lose time on the long run. So TDD increases agility and productivity. The next is TDD reduces the cost by spending much less time on debugging. Well, TDD is all about frequency of feedback. It let us fail only a little with a small cognitive overhead where the changes are cheap. It helped us to prevent doing mistakes by doing this. Debugging, I'm of the opinion that debugging is a sort of smell. I mean, being expert in debugging is a smell. And by doing TDD, since we verify every step what we do, therefore we always know that our code works, so we don't need to spend time on debugging. And debugging, what is debugging? Debugging is it's unproductive activity. In debugging, what we are doing is checking how our code works, because we don't know how it works, right? I mean, if someone doesn't use TDD, they don't know how their software works, so they need to use debugging to figure out why. And managers would be surprised how many hours per week a developer spends on debugging. They spend a lot, multiple hours, even more, and it's an unproductive activity. It's a waste of time. And by TDD, we can almost prevent any debugging. And here it is, selling TDD to management. How shall we approach this topic? Well, let's use an example. For example, when we want to have our car repaired, right? And we take it to the garage, and after that we get our car, we are happy. We don't ask the people who fixed our car that what kind of tools they use, right? Usually we don't ask. We just care about the result. And usually, or most of the time, that's what management also does. They don't care about what kind of tools we use. They care about only about the result, whether we write bugless working software which fulfills or which solves the given problem domain. And yes, and it's a good thing. I mean, for example, refactoring and testing is our territory, right? Management should nothing to say about this. It is part of being a good software professional. On the other hand, we have to understand this, and I think that's why it's important to heads up with this, that TDD is a different beast. TDD is not something that we take and we plug into the development process and it will just work, and we will become super productive, agile, with less bugs and less debugging time. It's not how it works, unfortunately, because TDD requires, first of all, TDD requires cultural change, both in the management and in the developers, in the development team. In the management, first, the management should understand that TDD is an investment, and they should provide the environment where the developers can be trained. I think Alan Holub said very well in the past that training developers can make them slow, but not training them can make them slow forever. So here is the thing that they need to understand, the management should need to understand that they would need training. And why they need training? Because the TDD itself is not, the rules of TDD are simple, but executing those and executing TDD workflow is complex because TDD requires three, I'm of the opinion that it requires three main skills, technical skills, in order to apply it efficiently. First of all, TDD requires knowledge in writing tests. We write different tests for a React application when we do TDD, and we write very different tests for example, a .NET Core backend service. So therefore, developers would need to know. And nowadays, a lot of developers still don't know what kind of tool set they have in the given language, in the given framework they can use to write good tests. The second skill, which I think also very important and a requirement for TDD, is writing clean code. And why it is? Well, the third step of TDD is about refactoring. We want to apply refactoring. TDD won't tell you how to refactor. TDD won't tell you what kind of namings you should use. TDD won't tell you which design pattern you should use. It won't tell you how to name, how to structure the code, and a lot of things, how to do the refactoring. It will just tell you that, hey, it's your time to revisit your design. It's time to refactor. Something is wrong. Maybe it's not testable. So this skill is also needed. Without that, it won't work. So if someone doesn't know how to write clean code, then what are they gonna do in the refactoring step? If they don't know how to write clean software, then they won't do anything in that step. So it's needed. And the third one, and this is I think the most important one, writing clean tests. Clean code requires clean tests as well. And clean test here, I mean for how to name our tests, how to structure our test, what to target, right? Because we have to target behavior and not a code structure, because if we target the code structure, then our tests can become too fragile. So, and here's the thing: if they don't know how to write, if they, for example, let's say they know how to write tests, they know how to write clean code, but they don't know how to write clean tests, then TDD won't work. And the tests will just become burden for the team. It will just make them slow, and they won't get the benefit of TDD. And last point, which we should understand, is forcing never works. So it's okay that we sell it to the management, and let's say they are sold, so they are happy to apply, they're happy to invest in this skill for the development team. But forcing it will never work. There is nothing good coming from forcing TDD. The developers themselves need to understand the advantage of TDD. And once they understand it, therefore, they should be willing to apply TDD. Of course, with the support of the management, who provide an environment to where they can learn this skill. So that's it's all about, as I said. And so it's very important to sell it to the developers. So it's not enough to sell it to the management. We need to convince our colleagues to apply TDD. They need to understand the advantage. And my second part of my presentation, it will be about convincing your colleagues to apply test-driven development. Just a second. Okay, convincing your colleagues to apply TDD. TDD has a silver bullet. It's a bit controversial title. First of all, we have to talk about what is a silver bullet. By definition, I checked it out before this meeting. Definition of silver bullet is something which we can use to kill a werewolf. If we want to translate this to software engineering, silver bullet would be something which can provide solution for every problems, right? And as a matter of fact, and unfortunately, there is no such thing silver bullet in software and industry. There is no such tool which can be used to solve every problem in this space. But if I would need to name one thing which is close to the silver bullet, which we can help a lot, I would say it's TDD. Still not a silver bullet, but it is the closest thing which you can use to solve most of your problems. Actually, TDD won't solve all your problems, but it will prevent many of them. It won't make you much faster, but it will make you much more efficient. So it is not a silver bullet, but I can tell it's a magnificent tool. So let's see about the reasons why it is a magnificent tool. Seeing or test failing. One is the most important reason to use TDD to see or test failing. Why? Because we want to trust our code, right? If we want to trust our code, we need to be able to trust our tests. If we want to trust our tests, we need to see them failing. If we never see them failing, then we don't know if we actually testing the right thing. A test failure validates that the test is meaningful and unique. A test is also a software expectation to fulfill. And finally, it gives us a target to aim for, showing that the code we are about to implement is useful and necessary. So it results in a unique and meaningful test. We have to run it. We have to see it failing. And test after development, you don't have this. You don't see it failing, right? Because you write some production code, after that you write some test, it's green. That's it. Do we trust the test? How can we trust in those tests if we never see it failing? It's crucial. It's just super important. And this is the main killing features of TDD, that we see or test failing. So it verifies, validates that the tests are unique and meaningful. It can also prevent us to have false negatives, right? Because we know why a test is failing. We know the reason. We see it failing. So we can prevent false negatives. What are false negatives? False negatives are passing tests while we have some bugs in the code. And yeah, if we see it failing, we know why it fails. So we won't produce tests which will just pass for the sake of passing because we have an assert true, for example, or a non-meaningful test, non-meaningful assertions, or even without assertions, right? I have seen examples. I've seen tests where there were no assertions. So what do they expect from those tests? They are always green. They are not. They were just written for the sake of writing tests, not for having a strong safety net. And of course, good thing is, I mean, when we write our code, we have the most current knowledge about the code we produce. We have the domain knowledge, and this domain knowledge we want to capture. We want to capture and we want to put it in our tests, because tests are also sort of expectation. Also, we can capture the requirements. They are sort of specific executable specifications. And when we write the code, we have the most recent knowledge about the code we are writing, about the domain. So we can capture this in a test. And the more we wait with writing tests, so we do it afterwards or do it later in 1 week or in some days, we forget a lot of important knowledge. So we cannot capture this information. So a test won't be that quality because it will miss a lot of information, and they cannot act as a good documentation for a code we are producing. Next. TDD helps us to produce high quality of tests. First, we have to talk about what is code coverage and what is mutation testing. Code coverage checks if our code is executed. That's it. It checks whether the code is executed by the given test, whether it's reached, and that's it. It doesn't tell anything about the fact. It doesn't tell anything about that the given behavior is asserted in the code or not. It is a misleading metric. We can have 100% test coverage without any test assertions. Code coverage doesn't tell anything about the quality of our test. Actually, it has zero information about the quality of our tests. I can, if you, for example, it's new to you, this information, I recommend you to go to your code base or go to your project you are working on, or if you are a manager, then go to your team and ask them to check them test and run the code coverage tool. First of all, check your code coverage. Let's say it's 95%. Very good. We are happy. They are celebrating that they have a good test. No, ask them, or it's your project, do it yourself, that you remove all your assertions. So at the end, the verification part of your test, remove all of them. And after this, run your code coverage tool again. And what is the result you will have? You will have the same result. So if you had 95% before removing all the assertions, when you remove it, but after you remove and you run again, you will have the same result, 95%, but with 0 assertions. They are always green. So code coverage doesn't tell anything about the quality of our tests. So we need something more, or we might need something more. And here comes the mutation testing. What is mutation testing? Mutation testing is a relatively simple technique. What happens when you do a mutation test, you can either do manually or in an automated way, of course, if you want to save time. You do a small mutation in the production code. Mutation can be, for example, arithmetic mutation. For example, you change a plus to a minus, or you can, for example, do conditional mutation. You negate a boolean, or even you can do a statement mutation where you remove a complete line of code. And once you did that small mutation, that small one, let's say the arithmetic mutation, we change the plus to a minus, and after that we run all our tests, and we check whether our tests are able to find the error in our code. Because what did we do? We produce the bug, an artificial bug by us, right? We produce that bug in the code. We remove something or we change something around, and after that we executed all our tests. And if anyone accidentally we produce a bug in the code, then we want to be sure that our tests are able to catch that, so they can act as a regression test. They can help us to tell, hey, you made a mistake, you introduced the bug. So that's what mutation frameworks are doing. They are generating a lot of mutation of your code, and after that, for each mutation, all the tests are executed. And TDD helps to produce high mutation score. And what is mutation score first? So we know what mutation testing is. Mutation score, before we talk about what is mutation score, we have to understand two things relating. One is kill mutant and surviving mutants. So again, get back to mutation testing. We or the framework we are using does a mutation in the source code, in the production code, and after that, it runs all our tests for that mutation, for the whole production code, all of the tests. If we have a failing test, it means, oh, very good, then our tests are found that bug we produced, then it's fine. We are super happy, right? We know that our test suite is strong enough. If, again, we make the mutation and run the test, and we don't have a failing test, so we have all of them passed, then it was not good enough, or test suite is not good enough to find the bug in the code we produced or the mutant. So it is a surviving mutant. So what is a mutation score? It is a number of killed mutants divided all the mutants we or the framework generates. It is, and of course we have to multiply it by 100 if we want to have a percentage of it, so we can have 100%. And TDD helps us to produce high mutation scores. It means the higher the mutation score, more it means that our tests are checking the behaviors we have in the code. And TDD helps us to produce that. And without TDD, we don't have it. And why it happens? Because it's coming from the TDD flow every time. So we can write only production code in the TDD cycle when we have a failing test. So we are sure, I mean, it's coming by design from the flow, that for every feature or every code we write, we will have, during the flow, we will have a red test. So every behavior will be tested. So it guarantees a high mutation scores. And test after development, you don't have this guarantee, and you have much less mutation score. And here again, a good practice to you, if you check the previous, if you have done or if you are planning to do that previous practice to check your code coverage by removing the assertion, I recommend you to check out or find the mutation testing framework in your stack. You can find surely for all the famous languages, you can find and execute it. And you will be surprised how many gapping holes you have in your test. Namely, your tests don't cover all the behaviors you have written. So it means you have more surface to introduce bugs in the future. Because once you introduce a bug, a mutation, but you do it accidentally by doing a merge or I don't know, or just writing some code, or test won't tell you, hey, you made a mistake. Or your test will tell you, hey, everything is fine, let's push it to master, and your customer will find out, so your reputation will decrease, and you have to pay a lot of money to fix that bug. And here is the thing that you can tell me, okay, Danielle, TDD is very nice, but I'm not interested. I can still do test last development. I can use code coverage, so I can find out which part of my code is not touched. And I can use mutation testing, where I can find out which part of my code, which the behaviors I'm not asserting in my test, and I can improve the test suite. So they will be strong enough eventually, or as strong as the TDD. Well, it's doable, but it's very time consuming. Just imagine that you need to do this mutation. For example, this mutation testing, what it does again, it generates mutations of your code, and for each mutation, it runs all your tests. So the more the mutations are generated, the more it needs to run all your tests. It's time consuming, very time consuming. Second, it's very technical. So mutation testing will tell you, hey, I removed the line 77, but all your test passes. I mean, the tests are not able to find this bug. What do you do after that? It's very technical. Line 77, okay, what is line 77? Okay, it's something, maybe it's not named very well. It's difficult to come up with the correct behaviors. Here comes the point. You don't have the domain knowledge. Why? Because you already forgot it. Or other people has written the code, so he or she knows the domain knowledge. So it's very technical, difficult to fix these gapping holes. Therefore, it's also demotivating. I think many of us can relate here. It's a sort of, I would call it a sort of duct taping, right? We write our code, and after that we use other additional tools such as code coverage, mutation, testing tools. We run them multiple times, we fix them, run them to have a good test suite. It's super demotivating. But if you really don't want to use TDD, then I would say these practices are mandatory, or it should be mandatory if you want to make sure that you have a high quality of test suite. If you use TDD, these tools are, I would say, optional. Why? Because of the flow of the TDD, or code coverage will be always high, because we always have a failing test in the flow of TDD. So everything will be tested. So everything will be covered, every business logic. And of course, everything will be also asserted because of the flow. Again, the failing test, everything will be asserted in the flow. So we will produce high mutation score. So these things, I mean, high mutation score and high coverage are guaranteed when you use TDD properly, and I would say they are just optional. Of course, you can still use it as a sanity check to look at it. We are humans, right? We make mistakes, we are tired, we miss some things. It's still good to have them as a safety net to run them in a CI pipeline, but it's optional, because if you do TDD very well, that these things will be maximized. Next is quality must be built in. I'm of the opinion that you can't inspect quality into a product. The quality must be built in the product. We cannot add quality after the fact. We can add quality only during the development process. And how can we do that? We can do this by testing every step along our way. We are keep testing and refactoring our software all the time, always. It's happening, because if we don't do this, then our test or code base can start rotten, and they will be less and less maintainable. So that's are the great things with TDD. It comes with a continuous refactoring, because it always reminds us to revisit the code structure, the namings, and basically the whole shape of the code, so we can apply refactoring almost every minute. It also helps us to cover edge and corner cases, because we always have to, we are thinking from the client side, what kind of edge cases we want, what are the corner cases. Also, it will help us to produce better test cases. And of course, readable and meaningful test, as I mentioned in the previous slide sheet, because we can capture the domain knowledge when we write the code. We cannot do it after. We can do it, but it's less efficient, and we can't get the full picture of the domain later. We can have it only when we write the code. So I have to keep testing, refactoring along the way, and PRs here unfortunately won't help. PRs here, the pull review and the code reviews when you do it later. For example, with GitHub PRs, unfortunately, they won't help. Usually PRs, in my experience, they usually, I don't see comments about, missing edge cases, or missing corner cases, negative cases. You can PR is a good tool. I mean, it's good to share knowledge, but it won't help you to inspect the quality, and it will help you a bit to increase the quality, sort of duct taping again, but it won't have the same effect like would you have, for example, with pair programming or mock programming. But this is another topic. We could have another session about this topic. So I will jump to the next session. My next slide sheet. Sorry. TDD. TDD is a design technique. It's not a testing methodology, it's a design methodology, but it has things to do with testing, right? Because we produce test, a byproduct. We have good test, good shape, they are in a good shape, their specifications, so it has things to do with test, but this is mainly a design methodology. It helps us to produce, first of all, a testable code. The testability comes by design. Why? Since it's write tests are the first users of our application. And here, since we write the test first, we make sure we make sure that the production code we are writing, it's testable, because we have to write tests before we even start producing it. So therefore, it really helps us. We cannot go to the green phase to make this failing test pass if we don't have a failing test, and we only have a failing test if for the public API, if we can produce a failing test for that. So therefore, it makes sure that the code will be testable. It is also an improved user experience, because again, the tests are the first users of the code. So we can check already that whether it's useful, whether the namings are useful, the input parameters of the public APIs, all the things, we can already verify it, because tests are the first user. We can already verify if the UX, the usability of the given API is good enough, because we are probing it. We are already using it in the failing test. So as you see, it's super efficient, because even before we write any production code, we already testing it, the user experience. We're testing whether it's usable, whether it's readable, the public API is good enough, the parameters, etc., whether it's clean enough. Before even writing the code, we are testing the user experience. It's just super powerful. And of course, we have this enforced refactoring. I already mentioned, I think, that we need to think about refactoring. It helps us to think about and to revisit the design, so we can keep refactoring. So it's sort of, it will improve the design all in all. Additional benefits. There are 3 additional benefits of TDD. Apart from these I just mentioned, first of all, it can help to minimize the geek at keyboard activities. What are the geek at keyboard activities? These are, for example, the debugging, manually typing test data, messing up with the configuration, such things. It really helps us, because we test everything. We are, or design, or the way of we write the code, it's guided by tests, automated tests. So everything will be verified. Every step we do is verified. So therefore, the debugging time will be minimized. And that's why I said at the beginning that debugging, or being expert in debugging, is a smell, code smell. It means that we spend and waste too much time in debugging, so we became an expert. It's still an important skill, right? I mean, it's not black and white software engineering. It's not always a greenfield project. We can have legacy software. So so we need to debug and other stuff. So it's an important skill, but still, if you apply TDD, you can almost forget using the debugger. So it's super efficient, and I think none of us like debugging, so it can also help us to go better. Next is TDD. It helps to reducing the mental load and managing complexity. Here is the thing. Can a juggler hold 7 balls in the air? It's possible, right? But due to complexity, it's easy to fail for them. The same happens in software. Can we hold 7 different items, 7 different ideas in our head, merging them together and coming up with a solution? Of course we can, but it's very error prone, very easy to fail, very easy to make mistakes. And really that's where TDD helps, because in TDD, we need to focus only one thing. We need to focus to make the failing test pass, the next failing test pass. That's the only small thing we need to focus. So it will help managing complexity. And I think we can all agree that there are the two most challenging parts in software engineering is managing people and managing complexity. And TDD helps us to manage complexity. So it's already a half win. And here is my, it is the last benefit of TDD, but it's my favorite one. And I think this is one of the main reasons why TDD is successful and why it really makes it superior to test last development. TDD is a joyful process. The joy comes from the sense of progress we get from doing it. It is a sort of game-like feeling, right? When to structure and design code in a turn-based way with exact goals to achieve. In turn-based way, here I mean the red-green refactor. We always have the turns. The results of these steps are immediate and visible, and it really helps to boost the morale and increase the creativity and the productivity. And here is the thing. Test after development loses most of the joy of writing tests. And namely, that's why developers don't do it, or they don't do it properly, because it's just not fun at all. So that's was the last thing I wanted to mention here about TDD. It's a joyful process, and it is one of the main reasons why TDD can be applied successfully and why it's superior to test after development. Let's do a short summing up what I was talking about how to convince the developers to apply TDD. First, we have to see our test failing, right? It's essential. We really need to see it failing. It is a crucial part, because by doing so, we know that the tests are meaningful and unique, and the test we are about to write is what we want to do. It's trustworthy. It helps us to producing trustworthy test suite with a high mutation score, as we've seen, because of the flow, right? We have everything tested and properly tested. So every behavior we are writing or we are producing by the codes will be asserted, verified by our test. So it minimizes the surface for introducing bugs in the future. Built-in quality. By doing so, we will have the quality built in because of the flow again. It's a design methodology. Yeah, it's a powerful design technique which helps us to produce testable code with better user experience, where we apply continuously the refactoring step. Thank you very much for attending, everyone. Before we go to the QA, yeah, you can find me on Twitter if you have any questions, or if you want to chat about these topics or any other topics in software engineering. You can check my website for some blogs, or even ping me, drop me an email. I'm happy to talk about these topics further if you have a question. And again, thank you very much for being here that long.
Yes, in this session we received, it was quite an active chat and a lot of questions. So I would say we can go on to the questions from the audience, and maybe if we still have time, then I will also ask some questions. But anyway, there's plenty of questions here.
Wow, let's do it.
Yeah. Okay, you talk about the cost of finding a bug in production. How about the same bug reappearing after fixing it, and how TDD addresses it?
Well, the first thing I do when there is a bug in my software is that I write a failing test for that. I do the same thing when I do for just writing normal production code for implementing a feature. I'm writing a failing test for the given bug, and after that I'm fixing it. So the same bug won't appear again because I already have it covered by a test, right? That's how I started. I started the failing test. After that, I fixed it. Maybe I have done some refactoring as well. So in the future, if I already covered the same bug, won't happen. It should not happen because I covered with a failing test.
Yeah, exactly. I think that that's a good explanation. And the key point there is that you saw the test fail, which means you reproduced the bug. In fact, that's the only proof that you reproduce the bug. Whereas if someone does test last, they just do the fix and then write a test. They actually don't have any proof that they ever even reproduced the bug.
Exactly.
Okay, the next question: where do those numbers come from? The cost of defects.
Yeah, I just hit it on my belly, I would say. So these numbers just came up with it, or I think I read it maybe some years ago. But as I mentioned, these are small numbers. So I think these numbers are moderate numbers. Lately, I'm working in a financial applications where we have a bug. Then for example, big exploit, then we can close the whole company. So as you see over there, it can be up to millions of dollars. So these numbers I just came up with these because based on my experience. But I think many of us can relate that these are moderate numbers, and we can have much higher numbers in the real life. But as I said, these are just in my opinion. Came up
Yeah,
with it.
it would be great. I mean, I think I had also seen a similar study which went into this. But if you ever find the original link, perhaps you could post it on
Okay.
Meetup, just because it might be useful. I mean, even though for us it's common sense, but for management, which is, for example, not aware regarding the problem of not having, automated tests in general, let alone TDD, then these kind of numbers actually can be part of how shall I say, better presentation of the issues when there's no test automation. So yeah, feel free to send a link if you do
Yeah,
find the original
I
source.
will try. It would be nice to have a source. It is a good question. So as I said, just based on experience, or maybe I read it several years ago and I had it
I
in
think
my.
I read it as well, but yeah, if you
Yeah,
find it, it would be excellent. So we have this interesting one, basically about stopping buying agile certifications and buying clean code books instead. So yeah, I'm just interested in your perspective regarding this one.
Yeah, exactly. It's an amazing thing what I heard from my friends, and I totally agree with this. I mean, nowadays, they try to sell snake oil, and with the scrums and all the things. And it's not, as I mentioned, agile is not about applying a rigid framework and following it and having everything in Jira. It's more about delivering value early to the customer. With continuous feedback and with continuous improvement. And yeah, I mean, instead of really if you want to be agile, instead of the certifications, we should focus on writing clean code where the cost of change is minimized, and we can apply continuous integration. And if we can apply continuous integration, we can apply continuous delivery, so we can deliver the software really quickly, so we can get the feedback, so we can refine it, so let us fail only a little, so we can drive the scope of the project based on that. So yeah, I really agree with Maxi friend, that clean code books really are excellent place to learn these things.
Yeah, definitely, because in the end, if we look at any other profession, imagine people who are building houses or soccer players. What's the first, improvement that someone should do in a soccer team? Okay, well, aside first, okay, morale and psychological safety, but then the very next thing is actually playing soccer. Like,
Yeah.
that's the essence. Or if you want to improve um, the way that people build houses, will focus on how they're laying bricks and how they're
Mm-hmm.
actually building the house. That's the essence. Sure, there could be, project managers walking around, but that's on top. So this is something which also frustrates me when people forget the essence, where in software development, not marketing or finance, like, let's firstly improve the software development practices before we do anything else.
Exactly. Yeah, because most of the time we spend is to reading the code, not writing the code, right? I mean, we have to understand it, we have to extend it, maintain it, adding new features, and if it is not in a good shape, then it will, it is we will have hard times with changing it or adding new features. And yeah, if we have a clean code, then we can really minimize the cost of change, and we can deliver it early and often with high confidence, of course, because we have a strong safety net. So yeah, totally agree with what.
And I mean, maintenance cost. In the end, the biggest cost of software in the lifetime is maintenance cost.
Yep. Yep.
And the only way that we can reduce maintenance cost is, reducing the risk of change, so we do that with automated tests, and the other part is increasing the readability of code so that the actual change takes less time, so it actually has economic impact.
Exactly.
Okay. Debugging means that you do not know how your code works. That will be a golden quote for me from now on. Indeed, it is. It's like the word is debugging, trying to find the bug. And if someone actually has to do that, which many people are doing, it means we have a missing test. Because if we actually had a test, the test should point to us what's the issue.
And not always, yeah, guess, and not, I mean, it's a bit confusing word, right? Because debugging, we have this debugging in every IDE or code editor, and it's about, spinning up the, the code, spinning up the code, in the editor, in the execution environment, so we can check how the code works. It's not always, we don't always looking for bug. We just want to understand why my code works, because I don't know, because my steps were too long, right? We took a big step. So, and after that, we don't understand, okay, why it doesn't work. Let's put here a debugging point here, a breakpoint here and there, and let's step through the code and see how it works, what are the values. And TDD, you don't need to do this, because you sort of automate the debugging, right? Or because you always have this automated tests for short baby steps, and you verify, you go again, verify, go again, and so you will always know that your code works. If someone goes to you and asks whether your code works, you can confidently say, of course, if you are in the middle of failing test, then you can tell, sorry, my code doesn't work just for that failing test, but for the rest of them, you can say, yes, I'm confident that it works. Every minute we have this confidence, and we don't spend time on debugging, which is really an unproductive work, because it doesn't produce any value, because we're just checking, we are just, as it was quoted, means that we don't know how our code works. We want to figure it out.
Yeah. And debugging is a big problem, because if certain teams don't have, for example, unit tests, then they might spend most of their day in debugging, and the problem is that debugging has to be just repeated, or even worse, some teams use debugging to onboard new colleagues. So when new colleagues come in, there's no tests where you can find out what's the expected behavior, but instead they say, okay, now we will do debugging together, and you will now discover how the program works.
Yeah.
Okay, so yeah, we have another one. Your unit test suite should also be used as documentation, and that is precious. So maybe you can say something about that as well.
Yeah, exactly. And there is one point that we get this with TDD, that since we have, when we write the code, we have the most current knowledge, or most current domain knowledge about what we are, what we are writing, the code. Therefore, we can capture this information, this domain knowledge in the test, because test should be functional, right? I mean, the name of the test, the variable namings, everything should be functional. If it's technical, it can be a smell that our tests are too coupled to the implementation details, so they can be more fragile and they can become a burden. So yes, here it is, and that's why TDD, I think it's very, it's superior to test after development, because you capture the information right away in your test, so they can act as a documentation in the future. So in the future, if you want to figure out why, what is this code about, what are the use cases, edge cases, etc., then you look at the tests and you can find out how your code works. Actually, that's what I'm doing. If I want to understand the code, usually most of the time, of course, time to time, if the documentation is good enough, I look at the documentation, but many times they are not in the best shape. So the first thing I do, I go and check the source code and check the tests and check how the given API can be used. If there are no tests, then maybe I won't use that library. That's also a smell, right? But it's another story. But exactly, the test can act as a great documentation of the code we are using, and we should produce it as clean as possible. That's why I mentioned that clean code requires clean test. Without them, TDD won't work.
Yeah, I think this is a great point about documentation, and we could also say that the word test is synonymous with executable specification. It's specification expressed through like an executable specification where we're specifying some expected behavior, and
Exactly.
that's like pretty much it. And the
Yeah,
other also benefit is that the test as documentation is always up to date,
exactly.
whereas human written documentation often goes out of date simply because it's too hard to maintain. And even if someone tried their best, it would still actually fall
Yeah.
out, I think.
Nobody maintains those, right?
Yeah, exactly.
The written, the static documentation.
So yeah, another advantage of applying TDD is that you likely end up with clean code. That's also precious. So I mean, for example, that's referring to the refactor
Exactly.
step, because in refactoring we're going to clean code. Is there anything else that maybe you'd want to add there?
Yeah, I mean, this is what it is. I mean, just to keep in mind that, TDD really won't tell you how to name your software elements and which design patterns to use. A lot of people misunderstand that if they use TDD, then they will end up having clean code. No, you won't end up having clean code. You need to know how to write clean code. And of course, after that, TDD will help you to remind yourself to revisit the code structure and revisit your design so you can improve it. Of course, clean code is not only about readable variables and function, is also about testability, for example, and TDD also helps you to help in those and better UX and all these things.
Yeah, and I will want to also add something else
Yep.
related to this. So, I mean, quite often when people write about TDD, they say, with TDD, you will end up with clean code. But that's, as you said, if you know what clean code looks like. If someone
Exactly.
has never seen clean code in their life, if they can't distinguish between two classes, or say this one's cleaner, this one's less cleaner, then they actually can't refactor to clean code, because the word refactoring, well, it means simply, okay, changing structure, as Fowler said, changing structure without changing behavior. Now the change in
Exactly.
structure hopefully goes in the positive direction if we know a certain positive direction, if we know what clean code looks like, but
Exactly.
we could also be changing structure in a negative way, going to worse structure. Now I know typically no one talks about that, but that's
Or
why it's important to have the skill set of like knowing what clean code is. As
yeah, I agree with that. I mean, we can go to another direction as well. As you mentioned, we can over-engineer sometimes the code, right? And it's also one of the biggest problems in the industry. It's not about that the code is under-engineered, but it is over-engineered, right? And it also increases the complexity, which is difficult to manage. So keeping it simple is the key here.
yeah, exactly. And this is why if someone does not end up with clean code, as they should not blame TDD,
Oh, yeah.
but rather do they have skill sets regarding clean code itself?
It's like when you're driving a car, right? When you end up in a different place you were planning to, don't blame the car, right? I mean, you are the one who was driving the car. In the same, like in the TDD, you are the one who are driving the development process. But where you end up, it's up to you. It's up to your skills.
Exactly. TDD is not a robot which
Yep.
replaces our
Yep.
thinking.
Yeah.
Okay, so another one. So writing clean tests, yes, this is a nice phrase. I guess it complements
Mhm.
clean code quite well, and I think we discussed it through some previous
Yep.
comments. Okay, TDD should be part of the development culture.
Definitely. So that's what we are all doing it, you and me and everyone. We try to spread the knowledge of applying TD. That's why we are here, right? I mean, we want to know how to reason TD and how to sell it, I'm not about selling, how to spread the words about it. So it should be part of the development culture, because unfortunately it is not. And as I mentioned, it should deserve a bigger adoption. Yeah, TDD, I mean, the rules of TDD are simple, but executing it in practice is difficult. It takes time to do. It requires the mind shift also in the developers, because instead of writing the production code after the testing, first of all, you need to come up with tests, and every time, every minute, every 2 minutes, you have to come up with another failing test. So it's really shifts from your focus from the implementation side to the client side, right? The client side meaning that how the code will be used, how it will be used, what will be called, with what parameters, and this is difficult. So I feel that's why TDD is not dead. I wouldn't call it dead. It's just difficult to apply in practice. Requires a lot of skills. It is still misunderstood, or people have bad experience with it. Of course, we need more teachers, trainers about this. And yeah, hopefully in the future we can make it more widespread, the TDD. That's why I created the TDD manifesto. I think that's why you are also very active, Valentina, in all the social platforms, so to spread the words.
Yeah, exactly. And I would say this whole concept of the development culture, I guess the ultimate foundation is it needs to be an engineering culture where quality is seen as the foundation, where people truly believe that it's logical for them that without quality you can't be fast. And then when people accept the need for quality,
Yeah,
essentially continuous delivery is like the level zero of
yeah.
achieving quality. Now continuous delivery requires continuous integration requires automated tests, and the
Mm-hmm.
most effective way of getting to the automated test happens to be all TDD. So it's like it's actually necessary for achieving that level
Mm-hmm.
zero, you know
Yeah.
of quality.
Actually, if you can add one more thing here, I was searching for this and why it's still not that widely used, TDD, and I was thinking why, because it's difficult or this or that, and I realized I think it's one of the main reasons that people, unfortunately, it is the sad truth, people don't care. People don't care about quality. Why? Because they go to work, they produce buggy software, they produce software with testing, with holes, and end of the day, they go home, they get their salary, and that's it. They can run away with murder, I would say, right? Developers can run away with murder, their process slips, and they keep producing sloppy and code with bad quality, and nobody will tell him, hey, it's a bad quality, or nobody tell him, hey, you spend 1 day on debugging, I'm going to fire you, or such things. There is a big demand for software engineers, and if you make mistakes, it's not like that we go to jail for 5 years. So therefore, of course, we shouldn't go to jail for 5 years. If we make a mistakes, the mistake should be embraced and we should learn from it. But what I tell with this, that people, unfortunately, they don't care, and they won't, not most of them, but many of them won't care in the future. They won't use, unfortunately, TDD. Of course, we should do our best to reason this, to apply it, but they just won't care, because they will get their salary, they can keep doing this up, and maybe it's not their passion. So that's what I was envisioning. That's what I was thinking lately in the last half year, that happens, and we have to face this reality.
Exactly, and maybe that's where currently there's a difference between software development versus other disciplines. So, for example, in medicine, someone is liable if they were negligent. So, if a mistake occurred, if it's not due to accidental mistake, but rather due to negligence. So, if they, for example, didn't wash their hands and it's actually required as part of the procedure, that would be negligence. Or similarly, if someone is a civil engineer and they just decide to ignore certain rules or guidelines when they're designing the structure, I mean, that would be another example of negligence, and they are liable for it.
Yep.
But in software development, there is no such liability. So the only people who are currently pursuing quality, from what I've seen, is only the people who have intrinsic motivation. So certain engineering leaders and certain team leads and developers who actually care about it. And for everyone else, it's like, okay, we're getting our salary. Why should we invest more in quality? And some companies also maybe get more money with hourly billing for the bugs as well. So that's another possibility that can also happen.
Yeah, exactly. Agree. Totally. Good point.
Yeah, so this, I guess, question was an interesting one.
Okay.
Okay. Yeah, so what a privilege to see the mastered work online. Okay, see some nice
Thank you.
feedback.
Thank you very much. Welcome.
Another one, okay, so test last one version was test later development. Other
Exactly.
one, test last development.
Exactly. Both of them, we do it after the production code is written. So that's what I meant. And test last development, but maybe test later. So also it, of course, so there are also differences, right? Sometimes you can write it in batches, right? Let's say you write a lot of production code. After that, you write a lot of tests, or you can do it in small steps. You write some production code, and after that, write some tests, write production code tests. You can jump between these. So, but test last development, it's what I meant.
Yes, I would say in terms of terminology that the one of test last development is what I've seen appearing a lot more in articles. So then that would probably be, how should I say, the closest match in terms of the acronym. And yeah, it can mean essentially three things, as you said. It can either mean, okay, we write a bit of code, write test immediately after. We can write a lot of code and then write test, which I think is the more common situation. And then the even more common situation is that we write lots and lots of code and we're continuously delaying tests and we never write the test, which I would say could even be the most common situation.
Yeah.
This last
Because it is, and also that was my last point of presentation, because it's not fun, right? I mean, it's just boring to do it. I mean, doing it after first loses all the joy of writing tests. So people won't, they will do it for the sake of testing, verifying the happy path, but that's not enough. We know it if you want to have a strong safety net. So, and that's where TDD shines, that you are having a big fun. It's a joyful process, doing it during the development process, doing the testing or writing your tests.
Yeah, that motivation difference is definitely a good point, because in TDD you're not like chasing after the tests. Your tests are your specifications, so it fits much more naturally. You naturally have to think about expectations before you implement. I still can't understand that when some people say, I want to implement the code and then see how it works, and I think to myself, but if you don't know what you're expecting, what are you implementing? So that's, I guess, one thing. But yeah, the issue is with test last. Typically, people are forced into writing tests due to someone from management saying, okay, we need to satisfy some code coverage number, and then people can write those assertion-free tests, which execute all the code, zero assertions, and everyone's happy and gets their salary, even though the tests are not doing pretty much anything useful.
Unfortunately, yes, that's the sad reality.
Exactly. And the other point that I also liked in your presentation about mutation testing, so TDD naturally leads us to a high mutation score. Test last naturally leads us to a much lower mutation score. It's very painful and very slow to have to run the mutation testing tool and to use that for like fixing up your tests. I can't think of a more like boring activity.
Exactly.
That's another, I guess, demotivator for test last.
Exactly, and what I found is this technical. As I said, it's very technical. So it feels, for example, mutation testing framework will tell you that, hey, here I negate from true to false. Then yeah, that's it. Do what you want with this, and what is it? Why? What is the behavior it's representing? What I need to write, run again, or it says I remove the line at 77, and that's it. And what can you do with this? I mean, how can you produce a meaningful test which really captures some domain case? So that's really challenging. And based on my experience, when I use this multi-agent testing framework after the fact, it was challenging to come up, and the result is not the same. So you can't have. That's why I said TDD is superior to TLD because of this. You can't have the same result without TDD. Yeah, that's the reality. We have to face it.
Yes, because in that case, someone who is under pressure might then simply just write a test like if greater than 0, return 4, if less than 0, return this. So they do
Yeah.
not go and find out what's the actual requirement. Now, there's also an additional danger. When we're writing with TDD, we are consciously thinking about expectations. So our expectations come first and then the code. But with mutation testing for test last, we're trying to extract expectations backwards. And it could be that the person who wrote the code was not thinking about the expectations, or maybe had wrong expectations, or they themselves weren't aware of the expectations. So I guess that's another negative factor.
Great point.
Another one, if your tests are coupled, you cannot run tests fast. This prevents us from using mutation testing. How would you advise companies with slow coupled tests?
Slow coupled. This yeah, great question. It's also some kind of two things because can be slow and coupled. But let's start with this coupled. Let's say it's coupled to the technical implementation, but they are fast.
Yeah.
That's an easier way, because over there we really have to find out what's your public APIs or the APIs which are used. For example, if you're a backend, the APIs used for a front end, you have to find out the boundaries and your APIs, and you have to refactor your tests and trying to target the public APIs and remove all the tests which is coupled to the implementation details. Of course, it's also far from ideal and not easy, but easier than the other one where you have slow test, because the problem with this slow test that they will run forever, right? So somehow you need to find a way to fix this mess. Yeah, here would be one thing to refactor the structure, the code structure, right, to make your test fast, but also keeping, let's say they are not okay, so they are slow but not coupled to the implementation. They are coupled to the public APIs, which is a really good point, but they are still slow because you use dependencies, a lot of IO operations, etc. And for that, and I think that's where a thing shines, called hexagonal architecture. You are also a big fan of this, where you can have your use cases, the business logic, the core logic, and we have the adopt port. It is also called port adapter architecture, and where you can have really the boundaries of your IO and all the external dependencies, and you can mock that out or fake them out, and you can focus on the business logic. So it's really challenging, but over there maybe the restructuring the code in a better way, so you can have a faster test. Then you can, but no, I just thinking about that. It's also not good because first of all, you cannot refactor your code, your code structure. You cannot refactor your application when you don't have good test suite, right? But if they are slow, but you really cover everything, yeah, then restructuring the code in some way. It will take some time because yeah, they are super slow, but I would say it's an investment. It's it depends how slow they take, but if I would say 1-2 seconds per test and you have multiple hundred or even 1,000, of course it will be super slow, but still if you do the refactoring and you do the mutation testing, you can have some gapping holes still, and you can fix those holes. Apart from that, yeah, what I also done is you can also do mutation testing manually. You can focus on small things. So it's always good to start small when you have a big problem. So here, for example, no, I just figured out, oh my God, it's a bit problematic to run always all the slow tests. It's very time consuming. I think that's why Maxi friend also asked it. In this case, I would keep it small, baby steps, and just changing small things, doing the mutation test, just a small part of the code base for a small module or for a small package, and improving that. And step by step, I would go in a small steps. So I wouldn't run the mutation testing for all the code base, just in a small steps, but in a small module, I would fix it and I would go for the next, if I have time, of course, if I have the money for that. So that's what I would do. Surely starting small, not for the vaulting. So that's what I would do.
Yeah, definitely. And I think it's good how you explain the difference regarding coupling versus speed, because, well, it's, I guess, two separate dimensions. When we're speaking about coupling, I guess there's two types of coupling. There's behavioral versus structural coupling. Now, both of those tests can run fast as long as everything is in memory. So then it doesn't matter, like, even if they're behavioral structured, or if they are coupled to behavior or coupled to structure. But if they don't touch I/O, they will still be fast. But it's the addition of that of I/O which causes the tests to be slow. So then the first step is it's essentially eliminating the effects of I/O, which is with hexagonal architecture. And indeed, even when I introduce TDD, which implies the usage of mainly unit tests for testing, like any key logic that we can do via unit testing, it implies that we have to essentially migrate to a hexagonal architecture as a first step, because then you can separate your unit tests from the integration tests with the infrastructure, and then the mutation testing tool can be run. And from practical experience, the way that I typically approach this is looking at any parts of the code which were directly referencing the database, or calling some external web service or whatever, those ones, to essentially replace them by interfaces. So, but it is a common challenge that the companies definitely face.
Great question. It's a challenging one as well.
Yeah, definitely. That one is an interesting one for discussion. What is your experience after selling TDD to your colleagues? Do you do katas with them so that they learn the mentality, the TDD cycle, etc.? Do you jump to use TDD on your project?
I think it's advisable to start, or when I recommend someone TDD or I try to sell it, I recommend them to, get familiar with the practices and doing with just katas, but it's just 1, 2, 3, or 4 katas, not more, just to, get familiar with the process. Because, if we are really want to apply TDD, it means that we are passionate about software engineering, so we can spend some, time even after work to work on some small dummy katas, right, which doesn't solve any business problem, but still we can get familiar with the practice. But only just a few katas. By the way, the TDD manifesto is over there. There are some katas and a great way to get started if anyone wants to start. But after that, I would jump away right to the project, but do it in small, baby steps, small things. Do it in a small part of the code, or a small function, or a small API, and starting it small. Because, as I mentioned, it requires a mind shift from your head. You have to think about the test first before you start producing code, and it really takes time to have this tick in your mind. it can take maybe for months, is that right? 1 to 3 months even for some people. So as I said, again, to repeat myself, the main recommendation would be start small, baby steps. Start with the small things, small functions. Of course, first start with some katas, 1, 2, 3. You can do it in one afternoon, not a big deal, or 2 afternoons. But after that, go for a real project and start with a small function or a small module, a small part of your code. That's what I would recommend. And after that, the people can get used to it, and they can, do it more and more and more.
Yes, and also perhaps pair programming with someone who already has practice in TDD, because if someone just maybe reads some katas from the internet, including advice to do a test per class or things like that,
Exactly.
they will end up with so many pitfalls. So it really helps if there's someone in the company might do pair programming, mob programming, to actually help the knowledge transfer regarding TDD.
Good point. Yeah, you need it's good to have a coach around. It's like the same like for a mentor, for any kind of other things. It's good to have a mentor who can help you and show you the problems you are doing along the way. It can really boost, it can speed up the process to have a mentor next to you who is telling you, or a coach hired from another company. For example, Valentina, feel free to hire her. She's very good in TDD. So it's good to have such a coach. But personally, or also in other people, I know a lot of people who picked up the knowledge of TDD without sort of mentors. Of course, we always have mentors in the real world, right? I mean, when we watch a YouTube video or read a great tweet or a LinkedIn post from someone, they are sort of mentors of us, right? So we can learn a lot from those people. We don't need a direct mentor, but of course, the mentor can always boost, increase the speed. Of course, you have a private mentor, personal mentor that won't be that expensive, but if you want to mentor for your team in the company, of course, it can be more expensive, but the return of investment will be very good on this.
Exactly, and I think that's where there's the difference. What's the motivation in learning? If it's someone's just intrinsic motivation, someone is maybe motivated about quality, most likely they will try to learn by themselves regardless of whether the company provides any mentoring or coaching. But if a company wants to get the economic benefits of reducing the maintenance cost, then the fastest way that exists is through coaching and mentoring, whether it's internal or external. Another also tip regarding this question is maybe not starting with TDD. So sometimes TDD might be too big of a step. Sometimes it helps, especially on working on real projects. Maybe sometimes it helps to firstly do test last and learn the mechanics. What does like a unit test look like? What does an integration test, and do a certain practice with firstly test last, so that people get used to how tests look like, how to write, tests, and the pain of changing the code, which was not testable, which is also a good learning, and then maybe later switching to TDD.
Yeah, exactly. That's what I mentioned, is that it requires some skill in order to apply it efficiently. So if you don't know those, like writing test, writing clean code, and writing clean test, then you will have hard time with TDD and you won't get the benefit of it. So these are just prerequisite for applying TDD. And of course, if a team, they don't know these practices, first you need to train them. Very good point. Thanks for adding it.
Exactly, because I've actually seen people being demotivated by immediately jumping to TDD because it took them, for example, 5 minutes to write a test because they've never written a test in their life. And then they say, I've now spent 5 minutes writing a test, and my code, writing the actual code, was like, 5 seconds. But that's because they've never written tests. When they get started writing tests, even with test last, then later that ratio reduces the amount of time they spend on the red step, so that they don't feel it as a burden.
Yeah, great question. Thank you.
Okay, you make them read clean code and you pair program them. So I think that this was also an additional answer to the previous question. Okay, so we have some positive feedback regarding your session. So amazing talk. Thank you very much.
Thank you, Maxi. Appreciate it.
Another thank you also from Peter, who will also be one of our upcoming speakers
soon. Thank you very much.
about also writing,
Oh,
what he
cool.
calls big unit tests. So that will
Yeah,
also be an interesting session.
try
Okay.
to be there.
If I already convinced the management, but I have a 10-person team without TDD experience, how much time do you think to teach them? This is a really excellent question.
And here comes the first of all that whether, so what are their skills, right? Do they know how to write tests? Do they know what clean tests are? Do they know how to write clean code? If the answer is yes, then it's not a big deal. I would say it would take, if they are really experienced, it would take some weeks, maybe some of them 2 months to really to pick up the mindset to write to do test first. So some weeks, month. But if they don't have these skills, first of all, it needs to be trained to them how to write clean tests, which is not a big deal, but still the most important, how to write clean code, which is a much bigger topic, right? There are millions of books, presentation about this, and how to write tests. Of course, it changes. How to write tests in a given language in framework, it changes from day to day. What we learned yesterday can be deprecated by tomorrow, but we can learn from it. So yeah, if this, as I said, just summing up my answer, if they know how to write clean code, know to write clean tests, how to write tests for the given stack, then shouldn't take more than 1 to max 3 months to really just to get this mindset and get this cultural mind shift that we write or test first. If they don't know these, then it's a big depends on their skills. It can take much more because you need to train
It
a
can
lot of
take
things.
even several months.
Yeah,
So
absolutely.
that's at least what I've observed. The situation is a team, and here we're not saying just without TDD experience, without
Yeah,
any test automation
yeah,
experience, because
yeah,
that's actually the most frequent
yeah,
situation. So it's not without TDD experience, but rather no automated tests at all, or
yeah.
hardly any automated tests. And
True.
my estimate regarding
Hmm.
this question is quite easily optimistically 3 months,
Hmm.
realistically 6 months,
Hmm.
or even more, because as you mentioned, they have to be even taught how to write tests at all. Even teaching people to write tests last
Yep.
can take months because they've never done it. Clean code, they can't do the refactor step right properly
Yeah.
if they don't know clean code, so that also takes time. And then the time needed to switch in their mind. Okay, let's say they've been trained how to do test last after some time. Okay, let's now switch this. How do we think from the specification? What's the expected behavior?
Yeah. Exactly.
How can you identify expected behavior? So yeah, the answer to this question is it can easily take 6 months, and with coaching or mentoring. And if they are left alone, it would take even longer than that.
And I don't want to judge the team. I don't want to go into judgments, but usually they have a room to improvement in regards of writing clean code. Such teams usually they are not perfect. They are not, and nobody's perfect, of course, but usually they have room for improvements in writing clean code, writing clean tests. So you're right, probably multiple months in that in this context.
Exactly. But in the end, it is an investment that pays off for the product long term. So we had another. Thank you,
Ah,
Daniel. That was a
thanks a
great.
lot for
Uh,
coming, my friend.
Would you mind repeating the mutation score? Or maybe if you could try to, re-explain maybe
Absolutely.
mutation testing, because that's something that not that many people have heard
Hmm.
of and not using. So again, reminding us what is mutation testing,
Hmm.
what's the purpose of mutation testing, and then also how do we calculate the mutation score?
Absolutely. So first of all, what is mutation testing? Uh, if you want to just do a simple mutation test, then we need to go to the production code. We do a small modification of the code, and we check whether we do a small modification. It can be an arithmetic operation. For example, we change a plus to minus, or you delete a line of code. So small mutation, and after that, you run all your tests. And if you have a failing test, it means nope, your tests are good enough to find this problem. And it is just when you do it manually, of course. And the mutation testing framework, what they do is they generate a lot of if they generate a lot of mutations of your code, a lot of like negations, a lot of kind of mutations, and for each of them your tests are executed, and it checks whether you have a failing test or not. And if you have a failing test, it means you kill the given mutation. Okay, so the mutation is covered by your test because you made some mutation, you run your test, you have a failing test, it means, oh yeah, my tests are good enough to find it, so it will be called killed mutations. And if for a given mutation you have a passing test, so it means your test don't indicate that you have a problem, then it means the mutant is survived. And how can we calculate the mutation score? Is that we have to take the number of mutants, so the total number of mutants we generate, or the mutation test generate for us. So the number of the number of killed mutants we take, and we divide by the number of all the mutants it is generated.
The total mutants,
a total. So let's say we have 10 mutants is generated by a mutation testing framework, and for example, 9 of them has been killed by your test. It means for 9 of them, for each of the 9, we will have a failing test. So it means that we have 9, and after it will be divided by 10, which is the total number of mutations. So it will be 0.9, which will be, if we multiply it by 90%. So 90% will be the mutation core in this case. And if you follow TDD, you will have close to 100%. Of course, software engineering is not black and white, but you will have close to 100 or around 90 because of that. I hope it was understandable. Sorry, my dog was jumping and biting me. That's why I was doing some tricks around. I have to feed her, but I'm still fine to answer questions.
Okay. We still have several questions, but maybe we can now speed up some.
Okay, yeah, let's do it.
Because we did get. It's great that the audience is engaged in this talk. Okay, so your 2 last additional benefits are the first one I present when I talk about TDD. I think crafters have been trying to sell TDD the bad way, and a follow-up one. We try to sell TDD as an advantage for software quality, which it is, but I think we should instead focus on developers. Try to sell it as the way to develop peacefully or maybe securely with higher assurance. And I think that's the argument which Kent Beck actually writes in his book, where he keeps on emphasizing safety. So maybe if you could just give a short answer, what's your thinking about this?
Yes, and that's what I also mentioned in my presentation, that it's not enough to say to the management, and management should not force it to developers. The developers should understand the benefits of TDD. And if someone cares about their craft, then they will see the benefits if they really want, because TDD is superior. So we have to state this. So it is not a magic pill or other stuff. It's not a snake oil. TDD works, and it's a magnificent tool. It's much better, superior to test after development. So if someone cares about their craft, they will understand the benefits of TDD. Of course, if it is communicated by someone, so they will start using it. Or they don't care, so it doesn't matter what you tell them. They just won't use it. So yeah, exactly. The developers, we should focus on the developers, not on the management, because there is nothing good coming from forcing it.
Exactly, the developers have to accept it first. And even if a company decides to introduce any mentoring or coaching, it should be because the developers recognize the need. If they're not feeling the pain of doing manual testing, then we'll continue with manual testing and debugging until the pain comes one day. Is another, I guess, thing to add here.
Good point.
The way I usually approach it is leading by example. Quickly enough, people will start noticing things improving and they are getting curious. So I guess this is the case where there could be one developer, who maybe is already experienced in TDD and leads by example. So I guess that's another
great addition. Thank you, Joe.
is doing katas a good way to learn and practice TDD, or is it too disconnected from the reality of business applications?
It's a great way to get started with it. I mean, to get familiar, but don't go that far and don't get lost with the kata tutorial hell. Just use it to get started with the main practice, to get familiar with the TDD flow, with the cycles, and after a few number of katas, 4 5 or max, just a few katas, 3 4 katas, I would recommend to try it on a project, a real life project, and do it small. So it's good way to do katas. So I think it really helps, because the thing is with TDD is, as I said, it's simple, but still executing it's complex. So someone should manage this complexity, and so that's why we should really make the task easier, because it's a kata, it's a simple stuff. So we make it easier, and we focus only the flow of TDD and how we can execute it. So we sort of manage the complexity at the beginning, but after that, once you get familiar with this, you can jump to your project, and you should jump to your project and start, small steps, and start applying it. So it's a good way to start, but don't get lost in the tutorial hell.
Exactly, I fully agree on that. And even sometimes if someone learns just from katas, but there's no practice on real projects, then they can actually apply TDD in a wrong way, especially if katas only show how to test a single class. Okay, the next one. How do you sell pairing mobbing with teammates so that they learn TDD on projects that ran using resource maximization? Each developer works alone on his or her task. And and I feel that this question is even bigger than
Yeah,
TDD itself.
it's bigger than it is. I mean, we could talk about in another session or for hours about this topic, because it's also not black and white. We have introverts, all these people. It's not super. We cannot sell pair and mobbing always all the time. But what I would say is that, like working some pair programming, it's like the same like TDD. And to be honest, originally I wanted to talk about TDD and pair programming and the killing features of these two. But after Valentin told me that be careful, it's a big topic, each of them alone. So let's pick one. So I picked TDD. But again, the pair programming has again number of unique features, killing features. You don't have it without it, and without it, I would say it's super efficient. Working with code reviews and working with isolation is it's the most efficient way to write software, unfortunately, and still it's applied by 80 or 90% of the teams, which is sad. It works when you work in isolation, and you don't know, work in isolation with the open source project, and with a different time zone, because it's impossible to do pair programming. But apart from that, pair programming is the way. Selling it, here I have experience to selling it, but I could come up again with such a presentation, what would be the killing features, and if that killing features would be presented, then the developers would understand that, oh my god, what we are doing here big mistakes. But I would say the biggest take is we don't have, so what I would tell to these teams, that we don't have asynchronous communication with pair and more programming. We work together with the same goal, at the same place, at the same time, together in one place. If we want to ask something, we have the knowledge immediately, instantly. The knowledge is shared. We do it. And here is the thing: programming is not about typing. It is about thinking. And together with the team, for example, together with the team, we can think very much better than alone. It's not about typing, it's about thinking. And together, two heads are better than one, four heads are better than one. And basically, this is the killing feature of TDD, that together, and also, of course, the team morale is very much better when you have the synergy, is very much better when you have a good collaborating team. So that's what I would say to this team, that be careful, programming is not about typing, it's about thinking, and together you can do it very much better. It's just that's just a fact. And with code reviews, you cannot do that. You cannot inspect quality after the fact. You can duct tape it, and even code reviews. Let's say you have, and let's face it, that's what we have in the industry. We have complex logic many times, complex problem domains. So let's say someone works in isolation, and after that, someone needs to review it. That person needs to understand the specification, the requirements, needs to understand the context, the code base, and he or she needs to come up with improvement points for that code base. It is super inefficient. It can take even days to understand, or they do, so someone spends days on understanding again the logic which was already understood by someone and written. So it's super inefficient way. So
Exactly.
that's how I would reason. But as I said, programming is about thinking, not typing, and together we are just better. And you can't beat it with working with in isolation.
Exactly. That was really well explained. Now, for the next part, we have a series of conversation which I found interesting. So I will
Okay.
just quickly show it and then go across the
Okay.
discussion. I think
Okay.
it's useful for everyone to see on YouTube as well. The most selling argument for a manager is the money saved. Well, the money argument that does work.
Mm-hmm. Cool.
A TDD won't make you fast, but makes you efficient. It promotes software quality. But then we have the comment, TDD gets you faster, so that it actually does increase speed.
Exactly.
TDD means less work to software testers. Keep going. It is true that the more that developers apply TDD, the less manual testing will need to be done by testers.
Yep.
We have another one. Could you recommend some book titles on TDD? Maybe, I don't know if you already have titles or if you can add some on Meetup.
I
But
would
if
say
you already know, yeah.
the TDD book from Ken Beck, I would say that's the Bible of TDD. Surely get started with it, and after that, start with 1, 2 katas and start in your project. But then I would say that's the Bible, and from that you can really understand the TDD.
Exactly.
That's best.
Another one, TDD does not lead to clean code. It allows you to express the talent of clean code. Well, I guess the first part we had previously discussed. I mean, refactoring might lead to clean code, but if someone is maybe not skilled, it will not lead to clean code. But I found the second part of this sentence interesting. Okay, so here someone's mentioning clean code by Uncle Bob. Also, the recommendation which Mikhail repeats quite often is the modern C++ programming with TDD. I also read it. It's quite well structured.
I should check it out. I will.
Now, we also had some topics about, can you say something regarding execution speed? Is there a real risk that you end up with very good tests but very slow as well? I think we had addressed that in the previous part, right? Like if it involves IO, it will be a magnitude order, for example, slower versus pure in memory.
Yeah.
And let's see if there's anything. Okay, we had some interesting comments which are about one developer, one resource. Pair mob programming gives you more than just investing in people in the same problem. What about knowledge sharing, learning about your tools, tips, what's around your module? This is a good one about knowledge sharing and reducing risk. And additional also comments, mob programming leads to better productivity, and pair mob is code review in live. And we also have a question about the slides. The presentation was very well presented and readable. So will the slides be available somewhere? Perhaps if you could upload them on Speaker Deck or wherever else, and then on your Meetup, you can share the link to everyone.
Okay. Otherwise, if I would forget it, or I try not to, please, you then ping me. Just write me in Twitter or you can find me in LinkedIn.
Yes,
please, if I'm happy to send it over, or if you tell me, I'm going to upload it somewhere and after to share. But I will try not to forget. So, but if I would happen to, please ping me. Feel free.
Yes, and another compliment, good talk. So I think you received
appreciate for everyone.
Quite a lot. And the other benefit around benefits, there is another great benefit, and it is the shortest feedback loop you have with TDD. I don't know other way to have code that works, which we are able to deploy at any moment. Another big thanks for all this smart moment. Okay. I guess this session did go longer than a typical duration. It's great that we had so much engagement from everyone.
Thank you very
So
much for
I
everyone.
want to say thanks a lot for this talk. I think you discussed definitely a really important topic. So rather than just talking about how to do TDD, you went into the why question of TDD, both from management and from developer perspective. And it might be useful to whoever is watching it can maybe get ideas when they want to talk about TDD with their colleagues and management. And perhaps people can also feel free to share this presentation with any other colleagues. So thanks again. Yeah, really enjoyed this session. Thank you so much.
Thank you very much also, and thank you for everyone to make this happen. Valentina, thanks.
Thanks a lot.
Then goodbye, all the best. Thanks again for everyone.
Thanks a lot. Bye, everyone.
Bye-bye.